Welcome back, students. In this video, we're going to look at the oxidation of alcohols. Quickly, let's remind ourselves of reduction and oxidation and how they're different from one another. When we look at reduction, we're talking about adding a hydrogen or removing an oxygen, sometimes both. When we look at oxidation, we're adding an oxygen or removing a hydrogen, again, sometimes both. If we look at the figure off to the right-hand side, what I notice is I'm starting with an OH here, and now I have 2 bonds to oxygen. So if I go from left to right, I'm taking 1 bond to oxygen and I'm turning it into 2 bonds to oxygen. So that's like I'm adding oxygen. That would be a process that we would call oxidation. Whereas going the opposite way is reduction. For the reduction pathway, we started with those 2 bonds to oxygen. Now at the end over here, we have 1 bond to oxygen and we added a hydrogen. You can also utilize oxidation numbers for this, but I'm not going to do that in my particular class because I think we can get away without it. For alcohols, they can be oxidized with a variety of reagents. But before we get into those reagents, let's talk about to the extent the alcohols can be oxidized. Before we look at the reagents that are used for oxidation, let's look at to the extent that different alcohols can be oxidized. I want to draw your attention to my primary alcohol here in the sense that it has 2 hydrogens. Those 2 hydrogens allow this primary alcohol to be reduced not once, but twice. So the first oxidation, where sometimes oxidation is abbreviated with brackets and an O in the middle. So the first oxidation will lead this to a aldehyde, but that aldehyde still has a proton here. And so we can further oxidize to a carboxylic acid. Whereas in this second example, we only have 1 alpha proton, which means we can only do 1 oxidation. And in this case, your secondary alcohol, its only option is to go to a ketone. Now for tertiary alcohols, you don't have any alpha protons. So you know what that means? No oxidation reactions. You have to have alpha protons or a alpha proton in order for an oxidation reaction to happen. So this is for primary, this is for secondary, and this is for tertiary alcohols. Let's focus on primary alcohols first. Primary alcohols can either go to the carboxylic acid, so be all the way fully oxidized, or they can stop at the aldehyde. And your product depends upon the strength of the oxidizing agent. If you're using this first one, this is strong enough to take you all the way to the carboxylic acid. This is a reaction where you're creating chromic acid within the flask, right? You're adding sodium dichromate and H2SO4. There are other ways that can be used to create chromic acid in the flask, so don't be surprised if you see another reagent that does a similar thing. Then we can also use something called PCC with the solvent CH2Cl2, which is called dichloromethane. PCC is a milder and more gentle oxidizing agent, and it's going to stop at the aldehyde. Now, if you're starting with a secondary alcohol, it doesn't matter which oxidizing agent you use, the stronger one or the weaker one, because no matter what, you're going to get a ketone at the end. You don't have any other option. Because you only have 1 alpha proton, you can only go to the ketone. Here's the problem with PCC. PCC is a chromate compound. But so is the sodium dichromate. But PCC has been replaced with some other oxidizing agents that are more green, which means less harmful to the environment. So if you see in your textbook these other 2 options, remember that they do the same thing that PCC does. That means that if you start at a primary alcohol, they stop at the aldehyde. If you start at a secondary alcohol, they'll go to the ketone. Let's wrap up. In this video, we looked at oxidation of alcohols. We said primary alcohols can go to the carboxylic acid if you use a strong oxidizing agent. If you use a weaker oxidizing agent like PCC or one of the greener alternatives, that is going to take you to an aldehyde. No matter what reagent you are using, if you're starting with a secondary alcohol, you're getting a ketone at the end. And then we looked at 2 alternate oxidizing agents that are safer for the environment that can be used in place of PCC. Thanks so much for your attention. This is Katoni signing out.